in business. I'm Mark Black. We're talking about how the cloud is transforming your industry. So, this is a pretty bold statement, right? Hey, your industry's in this state, it's going to be transformed, the cloud's going to do it. But this is really more of a hypothesis. I think there's a lot of things that can transform any particular industry, but today what we want to talk about is how the cloud is doing that. So first, let's start breaking down this bold statement, this hypothesis I made. So what's the cloud? I thought this was a pretty good definition. I found this just doing some Googling of like, hey, what's a good definition of the cloud? And in fact, this review article, if you were to go and look at it, is actually pretty interesting, and they make a pretty good, compelling case of the different ways that the cloud is changing industry. And they take a much more of like an economics type of approach than I'm going to do here, a lot of good data. Don't get to prove my hypothesis with a lot of qualitative data, but these guys, I think, do a pretty good job. But I'm going to summarize it here on the bottom. The things that I think about the cloud is that it's self-service, and it's on demand, and it's off the shelf, and of course it's globally available. So this idea that I can go out and just get computing resources whenever I want and however I want is really, really powerful. And this is a huge part about what the cloud is. And usually when people deliver products in the cloud, they deliver them in primarily these three forms. So there's infrastructure as a service, platform as a service, and software as a service. So infrastructure as a service is probably what a lot of us think about the cloud more than anything else. Like Amazon did this better than anybody. They were initially an infrastructure as a service provider, and they just are taking over the internet, doing a really great job at it. Platform as a service is a little bit different. It's taking that infrastructure and it's building something on top of it. You guys are familiar with things like Heroku. They have a lot of APIs, good tools for hosting. They consider themselves platform as a service. And all the big cloud providers like Azure and AWS also have offerings in this as well. They've built on top of their infrastructure, and now they're providing higher level services. And finally, there's software as a service, applications. Gmail, right? Gmail is an application, it's cloud hosted. That's how a lot of end consumers might interact with the cloud. And really, any cloud product is some combination of these three things. You think about if you use AWS, and their AWS console is a web application, it's software as a service. Whereas things like Lambda, one of their services is more platform as a service, and of course they have things like the Elastic Compute Cloud, which is just raw web servers and compute hardware. But the cloud is more than just the technologies. It's actually a new way of building software. And we have this term DevOps. It came out of cloud computing, the things that people were doing in the cloud. But what's amazing about this notion of DevOps and continuous delivery is that we're finding ways to apply these concepts to different types of software engineering activities. It's actually a big thing at NIWeek this week. We hear a lot about LabVIEW and its command line interface and how it enables these types of workflows. And having done this, I think it's one of the most powerful parts of using the cloud is not only using the technologies, but learning these skills. So what's transformation? So just a dictionary definition is up there. I'll let you guys read it. But transformation is always a pretty big thing, right? It's not a small change. We would call a small change a transformation. But even transformation has different extremes. The most extreme form of transformation is disruption. And it happens all the time, but no one wants their business disrupted. And you might have to transform the way you do business in order to keep from being disrupted. But there's also another way to go about it, and it's how most people might actually use the cloud to transform themselves, and is that they're leveraging it. There's this disruptive technology out there, like the cloud. It's not necessarily disrupting their core business. It might be orthogonal to their core business. But they're using that industry trend as wind at its back to be able to do something differently than what we've done before. And that can be really transformative. So finally, you got your industry. So it's us, right? We've seen the cloud transform a lot of industries, but I think what we're beginning to see is what it means for our industry. And I look at the audience and all of our customers, you guys are in a lot of different industries. And I consider itself part of test and measurement. But the IoT style applications, large automated tests, automated measurement, especially distributed measurement or geographically distributed measurements, these types of changes are coming to our industry. We've been doing these things for a long time, but it's the application of the cloud on these technologies that'll change things. So just summarizing this up, the cloud is a technology of tools and services. It's a new way of building and shipping software. And the application of those two things together, when done effectively, can lead to transformation, either to your competitor's business or to your own. So we've seen this transformation happening. So these aren't exactly test and measurement companies, but Salesforce. Salesforce came on with a completely different model than how Oracle or SAP worked. Oracle and SAP would send people to your site, they'd install big servers and big applications on those servers, and then you would use them. Whereas Salesforce took a cloud approach, and they were able to out-execute entrenched players in just the course of several years. Like, I don't think Salesforce is more than 20 years old. I think it's actually a lot less than that. Other things that have changed. IBM, the server company, right? Like, no company says server to me more in its history than IBM. But of course, IBM wasn't profitable with its server business because people were taking advantage of the things that servers normally get us in a totally new way, and it was eroding that business. But you know what really caught my eye when I was searching around for images for this part of the presentation was the ad right smack dab in the middle. Talk about kicking them while they're down. It's like, hey, we had to sell our huge business, and here's why. They put an ad in the middle. It's like Jeff Bezos trolling IBM, I swear. Here's another form of transformation and disruption, is Uber. Uber really is a remarkable story. They disrupted the entire taxi industry without buying a car. And they've done this by leveraging cloud computing and also mobile devices, but they're not done, right? This is the real big transformation, the things that could really change our lives and the way that we get to work or to school or any of those types of things. This is really, really important, and it's not possible without leveraging cloud technologies. As I mentioned really quickly, it's good to keep in mind that the cloud and what's happened in the cloud in the last decade get this huge assist from the modern mobile phone. So phones, especially when they first came out, were pretty low performance. And it led for the need for better separation between what's on a client device, like a phone, and what's somewhere else. Because that phone doesn't have a huge amount of horsepower to do a ton of business logic and also renders its UI. You want it to be thinner than that. There's better separation of services, and this allowed web services to become more uniform. They're more just data now than being the presentation layer as well. Of course, there's billions of devices. We hear about the cloud needing to scale. This is what drives the need for that scale. There's a lot of people out there that can connect to your device. And then always on, always connected. The mobile phone is really a remarkable achievement. It's like everything written ever in your pocket. It's just an incredible thing. But for our industry, what's really going to keep on pushing this trend is 5G and, again, the Internet of Things. So we've known this for a long time because we sell really high-performance devices. These high-performance devices can generate a lot of data. Especially in geographically distributed situations, we need to be able to push that data up to somewhere. And things like 5G are going to make that easier than ever because it's wireless, high-bandwidth technology. And there's billions and billions of devices, right? Think about it, like everything could potentially be connected in the future. And it's one thing we're talking about toasters and refrigerators, and all seems kind of trivial, but you think about industrial facilities and how many devices we could instrument a factory with or an oil refinery with, and the amount of data that all of those devices could be producing. And finally, because we're talking about edge nodes, devices that just sit there and run, they don't sleep like us humans. They can be producing data in the middle of the night, so the need to be able to scale really is there. And so to talk more about the details of what the cloud is and all of its technology, I'm going to turn it over to Michael Watson.
All right. So my name is Michael Watson, and I'm a chief engineer in application software. And I'm actually working with National Instruments right now to build a cloud product. That cloud product we'll talk about a little bit later. But that's not what I'm going to be talking about today. Mark asked me to talk about how the cloud has changed the way that certain aspects of the way we do business. And I'm going to start off by saying how the cloud has changed the way that you staff an IT center or build out a data center, because it really is different. One of the key aspects is a shift from capital expenditure to operational expenditures. This is actually huge. If you go back to the olden days of, say, a decade ago, if you wanted to add some new server capabilities, new applications in your company or offer some services to your customers, you would have to budget for servers. You would have to purchase specific servers. You have to pick the hard drive, the memory, the processors, things like that. You would have to put those servers into a data center with a raised floor, special power, special air conditioning, and all that stuff. Okay, now you don't have to do that anymore. The cloud gives us an alternative to building out that old style data center. This is really important because the infrastructure is available on demand. If I decide that next month I want to put up a new service, I don't have to go and purchase any of that stuff. Instead, I simply figure out how much extra it's going to cost per month, add it on to my existing cloud subscription, and I go ahead and simply instantiate that service. That service is a machine, or 10 machines, or 100 machines, whatever is needed. I don't have to budget capital expenses anymore. I still have to pay for them, but it's a different, it comes out of a different sort of cost center, a different sort of budgeting methodology, and more importantly, it ends up being cheaper. So that's critical. I also don't have to worry about that. How much RAM did I have? How much CPU did I have? If I make a mistake, it's easy. I can just pick a different machine. But I select that, click, click, click on a menu option, hit go, and bang, I've got a machine configured exactly the way that I need. That I would never have imagined doing that in the olden days. Something else that's different is that licensing is simplified. Think about, well, maybe y'all never did it, but I certainly had to. When I wanted to get a web server or an email server or a database server, if I wanted to get some technology that was from some particular company and use it within my environment, I had to go through contract negotiations, purchase orders had to be cut, licenses had to be created and things like that. It was really, really complicated. And that's not the case anymore for a bunch of reasons. One is that the cloud vendor is providing a lot of the software for you. They already have it in their environment, and all you're doing is saying, click, instantiate me this database server. Or maybe I don't need this database server, maybe I need 2 database servers of different kinds. Maybe I need a cluster of database servers, whatever I need. I don't have to go off and do all the complex licensing that I had to in the olden days. And that's a real big shift. It gives me, as an architect of these kinds of services, some real flexibility. It puts things in my toolbox that I might not otherwise have had available to me. So I really, really find this to be tremendous. That last bullet point is a key one though. Today, so much cloud software is available open source. That means no license is required, or rather there is a license, but it's a free license, and it's one that is permissive, that allows me to utilize the software without having to jump through all kinds of hoops. So much of the software that I, as an architect, use to build out key services is already available. I rarely have to actually purchase any. So that's important. Now there are some other key differences. I mentioned that I can simply instantiate my hardware, my servers, my hard drives, my databases and all that. My infrastructure has become code. I don't have to actually go and manually select by using a mouse and buttons and forms and stuff like that, what I want. Instead, I can describe it in a machine-readable document. Now, yes, I can go through Amazon and Azure and IBM. They all provide tools that let me figure out how to do it the first time, but then I can export descriptions of those things as a document that I can then put into source control. And when I want to replicate something that I've already used, all I have to do is submit that document, and they will read through it and script out everything. So for the cloud service that we're building here at National Instruments, there are roughly, say, 15 or so different computers that have to be instantiated within a cloud. And those 15 computers have to be set up in very specific ways with certain networking and subnets. The firewalls have to be configured in certain ways to allow this port in and this port out, and only connect from this thing to this other thing. All those complex configurations, we used to have to do those manually. You used to have experts that sat in dark places and punched on keyboards and drank a lot of caffeinated beverages in order to configure those things. Nowadays, if I want to replicate what one of those guys did, I simply submit a document. Very, very cool. And the fact that it's version controlled means that if I made a mistake, I could roll back to an earlier version with little more than a button click. There's some keys to that the cloud gives me in terms of staffing changes. Now, in order to staff my own data center, I had to have hardware technicians that knew how to assemble computers and plug things together, how to install operating systems and all of that stuff. I had to have specialists in administering a database. If I wanted to replicate that database, I had to have more specialists. If I wanted to configure my firewalls and things like that, that's yet another person. All right. Now, I don't know about you, but if you're wanting to do all of that with that many people, you're probably spending more than you might need to now. Because with the cloud, all the people that I just mentioned, they work for the cloud vendor. They don't work for you. You're not hiring them, you're not paying them. So your staffing is quite a bit different. You still have to have people who know about the databases, but maybe they just have to know how to use the databases. You still have to have people who understand the firewalls, but all they have to really know is exactly like which ports are going to be used for what. And they let the cloud vendor take care of a lot of those things. So instead of providing a big IT shop and then a separate engineering organization, you provide DevOps. Okay? We talked about DevOps a little earlier, Mark did. And what it means is that instead of having these two separate organizations, IT and engineering, or IT and applications, we create one team. And that one team shares both of those capabilities. But again, you don't have to have everybody who knew everything about the data center because the cloud vendor provides that. So you take that team, and your engineers, your application developers, are also the same guys who are running it. They are the same guys who are working directly with the database, who are managing that database. Your application developers are the same guys who are monitoring alarms and waking up at 2 in the morning if something goes wrong to fix it. And the reason they're doing it is there isn't a separate team. You can't just throw a problem over the wall from one organization to another. And so what we find is that your staffing is different, and you end up with higher velocity caused because of the communication, collaboration, cohesion, and continuous delivery offered by this new philosophy of your developers also being your operations guys. You gain some other flexibility because of DevOps, and one of them is continuous delivery. You might hear that a whole bunch during NIWeek this week. Continuous delivery means different things at different scales, but let me tell you what it means for me as a developer of a cloud-based platform. What it means to me is that when a problem occurred here on Sunday before before our Alliance Day on Monday, where, let's see, we had 60 or so machines all set up for people to come in and play with some of our cloud-based software. And when something was wrong, they were able to call me. I was able to sit down in my hotel and look at the problem, find the solution, push it up to the cloud, and have it fixed in 20 minutes. Now, we have pushed, in the last 90 days, we've pushed over 500 times to the cloud. It goes from our developer's desktop through a validation pipeline up to the cloud in, on average, 20 minutes. And we can do that repeatedly. And we can do that because of our DevOps culture, where we, the developers, are also the operations guys. And we've built ourselves a pipeline of operations tools that are standard cloud tools nowadays that lets us do very, very important stuff. Something else the cloud offers. It offers reliability. Why does it do that? Have any of you all ever lost data when your laptop hard drive crashed, or something happened at home, or your desktop failed in some way and wouldn't boot? All right, that happens because that's where your data was. In the cloud, that's almost never the case. Whenever I have data up in Amazon, they're going to replicate that 2 to 5 times. It'll be in not just 2 to 5 times in one data center. They're going to replicate that across on each coast of the US or in Europe or wherever I've asked them to do it. Now, what that means is that if something goes wrong within a data center, there's another copy of everything that I've got, highly reliable. And not only is there another copy, but the cloud vendors are highly motivated to actually ensure that you don't have downtime. So it may be that they detected that there was a hard drive problem, and they transparently moved my entire instantiated infrastructure over to another machine, and I didn't even know about it. That is magical. That is really cool. That is transformative. Disaster recovery. Now let's say that entire data center went down. Not a problem. My service is going to go down when the data center goes down. But the cloud vendor is going to ensure that my service is back up and running as fast as possible. It may be just a matter of minutes or hours before all of my stuff will be up and running in another data center. And that was not possible when I ran it in my data center. So, very, very transformative. One of the things that I hear, especially in our industry, is that, oh, I can't trust my data to the cloud because of security. Well, that turns out to be less true than people might think. And the reason is that security is very hard. Getting it right and having the right people to do it is hard. And also, Amazon and IBM and Microsoft are much better at it than you are. They are much better at it than I am. They are going to hire the best of the best and spend millions of dollars per year on security. And not only are they going to do it, they're going to architect all the services that I use so that they are secure by default, and I kind of have to go out of my way to make them insecure. Now, we all hear about leaks, we all hear about hacks and things like that. So I'm not saying that the cloud is completely locked up and you won't have a problem, but you are far less likely to have a problem with typical cloud software today than you would if you were building the entire system, the network, the applications, the firewalls, and all that. It is highly, highly secure, and it's something that I've really grown to appreciate. Now, there are a few engineering tools that are different, that have also been transformative. One of them is these cloud providers, the services they offer. We call these software stacks. Now, when we talk about cloud, do we mean that you have to use Amazon or Azure? No. When we talk about cloud-based services, we may mean that you are actually doing it in your own data center, but you're doing it with a set of software that makes it look like the sort of cloud that Amazon and Microsoft run. Okay, that's the roll your own approach. And there are some industries, especially aerospace and military, where they really aren't willing to go and put their stuff into a public cloud. They really absolutely have to have it secure. Now, there are far fewer of those sorts of applications than you might think, but when you have to do it, there are tools available. And those are the ones on the left. Or you can go to a commercial vendor, and those are the ones on the right. And you'll see some overlap. What's interesting is that you don't even have to build your own data center if you want to run your own stack, because you can run all the tools on the left on the infrastructure of the companies on the right. And that's really cool. So you do have some flexibility there, depending on what your overall requirements are. So what tools do they provide? Well, it breaks down into these core functionality: compute, web infrastructure, data storage, database, and then reporting, managing tools, and monitoring and stuff like that. So these are the core sets of tools they provide. And those are things you don't want to build up from scratch. That will take you days and weeks and months and lots of people. When they provide these, why not take advantage of it? Very, very cool. But these aren't all the services they provide. They have tons of value-added service, and every cloud vendor is going to offer tremendous numbers of their own proprietary value-added services, such as machine learning, image recognition, image encoding, or codec transformations. They will offer analytics and things like that. So anything that you might imagine you have to build on your own, if more than one customer wants it, they're going to build it. The cloud vendor is going to build it. If they're going to build it, why should you? Now here's the deal. If you use their version of these software or services, you're locking yourself into that vendor. So you need to think about that. But even in order to woo customers away from one vendor to another, some of the cloud vendors are supporting certain open standards for many of their proprietary features. And they're saying, yes, you can use the open standard and move your stuff from Azure to Amazon or vice versa. But we have these extra other added features that you might want to take advantage of once you're here. So those are cool things. All of these are transformative in terms of how you can build and run your services, whether you ever have humans having to access these services or not. You may be having your machines, your devices, your test cells, your sensor networks, your distributed monitoring systems. They may need to take advantage of this sort of thing, and you can do it now far more cost effectively and with way more reliability and far higher security if you use a cloud than if you were to build it yourself. So with that, I'm going to hand it over to Mark to tell you about how exactly NI is taking advantage of the cloud.
All right, thanks, Michael. So we talked a lot about what the cloud is and all the tools and capability that the cloud provides and how it's transformative to how people are building software services. But a lot of you guys aren't in the business of building software services. You're in the business of building and testing things in the real world. And what we want to try to provide is the tools and technologies built from the cloud to provide you the mechanism to take advantage of this trend in order to transform yourselves. And we expect this to happen in the industrial IoT space first. And long term, I think the way the cloud affects all the things that we do are going to be a lot broader than this, but this is the one that's the most pressing and that we feel like we understand the best right now. So the industrial Internet of Things is a lot of different concepts. You might take issue with some of the things I've thrown in under industrial Internet of Things here, but I got to write the slide. What's remarkable about IoT applications is that large test facilities or manufacturing lines look a lot like distributed IoT applications. They might all be in one building, but they could be producing more data than, say, machines that are monitoring trains or airports or something like that. So what are we going to do with this? So this slide shows just a generic IoT system, and it's trying to simplify it. And IoT things can do a lot of work, but it all sort of boils down to this common denominator. On the right, we have edge nodes. These are the physical pieces of hardware connected to the real world. It's PXI chassis, it's compact Rios, it's Windows PCs running tests. It could be third-party devices and third-party hardware, of course, too. And they're generating data and they're putting it on the network, which is being sent to a central node. That central node primarily defines security, authentication, database management for the larger system that it's servicing. And this is also the right place to stick in things like workflows or analytics. We saw a bit of this in the keynote today, right? We were ingesting all this data into a central server, and now that it's there, let's start writing applications that do something with that data and see if we can gain some more insights from it. And again, on the left, using network I/O, maybe the same type of network I/O, we publish administrative dashboards, web applications, different things for us humans to consume what is going on in this system. So this being NIWeek 2018, we're talking about SystemLink a lot. SystemLink sits in this space quite nicely. In fact, it is a really, really compelling product in this space because it does more than just the simple IoT thing of gathering data and visualizing data. It has amazing tools for configuration and software deployment. It can do all the monitoring and diagnostics. It's taking these types of concepts to the next level by plugging in better abstractions like hooking into test stand and generating test steps and pushing all of that data to a central server. But one of the key things about this is that SystemLink server is single tenant. And how many of you guys are familiar with the terms single tenant and multi-tenant? I am, a few of us. So I'm going to talk about this a bit. So single tenant means one server, one, we'll say, group of users. It might be one user, it might be a single person group, or it might be your team. So you think about, hey, we're going to use this SystemLink thing. We're going to set up an IoT style application in our lab. We have a SystemLink server. It sits under my desk. My team accesses it. That SystemLink server has a single tenant, my team. Multi-tenant is how much of the cloud and software services work broadly for the consumer public. Think of Google Docs. When you go and you create a new document in Google Docs, you're not talking to a single server that was spun up just for you. Like, that's what it would be in a single tenant sense. It's multi-tenant. It means there's a larger application out there, and the business logic of the application, the security model of the application is what keeps user data isolated and makes it multi-tenant. So we actually think that there's something we can do here, and it's with something we're calling SystemLink Cloud. SystemLink Cloud provides the same monitoring and diagnostics capabilities that SystemLink Server has, but it has a much narrower feature set because it's so new. But it allows us to take data produced by edge nodes and be able to do the visualization. It gives us a space to start plugging in things like fancier workflows or analytics or other APIs, but it's doing it in a multi-tenant way. And this is really important because now NI has taken on the entire burden of managing the server for you. So Michael had this story about how we found a problem and we were able to push a fix to that problem really quickly. That's huge to your advantage. Think about it. You're a developer, you're building a system, but you're going to take advantage of the fact that there's a bunch of very smart people at National Instruments looking at that system all day and all night to make sure that it's operating as effectively as possible. And of course, finally, you sign into it using your ni.com user account. I actually think this is one of the most important parts of this technology is that it uses that login. So introducing SystemLink Cloud. It's currently in the NI Software Technology Preview. If you go to ni.com/tech preview, you can go and enroll. If you're already part of the Tech Preview program, you already have access to this. It includes the system link tag and message services, which you can use in LabVIEW 2015 and newer, and also in LabVIEW NXG 2.1. It's secure and globally accessible with your NI.com account. And finally, it's open and it's delivered continuously. So a little more detail about each of these those bullets that I had in the previous slide, let's go into more detail, is tags. So what are tags? Tags are single point measurement data, essentially. In our sense, they're measurement data. And we can see here on the left, we have tag paths, which is a fancy way of saying name. And on the right might be the latest value. Single point, usually slow moving, live data that we're ingesting here. But really, really important, any type of IoT system needs this basic concept to be satisfied. One of the things that we encourage people to do with tags is to use dot notation to, quote, namespace the tag. And this is really important because our APIs are really powerful in their capability to be able to query tags. So you can very effectively have millions of tags in your account, but in your application, just query and open a few of those based on the particular path that they're at. This is a really important concept. Messages. Messages are really, really cool. And in some ways, I think they're more compelling than tags. We talk about tags all the time. Tags are great. We all love tags. But messages are really important for building complex applications. So messages are essentially a network queue. You have publishers and you have subscribers. You can have someone publish, an application publish a single message and have, I don't know, 100 compact Rios subscribing to that message. And they would receive that message and then they could enter, say, into a new state, like a standby state. And here's some examples of messages. Again, we encourage the dot namespace style naming. And that first message is start pump. And what I'm trying to describe here is, hey, I send a message to one system or maybe a whole collection of systems because I can do that with messages to go into the start pump state. Another thing that we can do is configuration data. So all messages are strings. Strings feel maybe limiting at first, but you can express a lot with strings. And here we're using JSON to express perhaps a test step or a configuration. So test configurations would be these big complex things, and we want to send them down all in one chunk. Tags are not a good fit for that, right? Like there's their latest value, polling. You wouldn't want to set a really complex test configuration by setting a bunch of different tags to different values. No, you want to be able to send this all down at once. I think this is a really powerful concept. There's this technology called the actor framework that's really popular in the LabVIEW community. Whenever we hear the term network queues, the actor framework thing should definitely be stirring within us because there's something that we could do there. And I think in the future, as technologies like WebVIs matures, System Link and System Link Cloud mature, we're going to have more information available on NI.com of how you can build really powerful interfaces into your application by using this concept. And no surprise, there's a G API for all of these. They're really quite good. The pictures here are of NXG, but as I mentioned before, they're available in LabVIEW 2015 and newer. And I encourage you guys to check these out and play with them. Another feature of System Link Cloud is WebVI hosting. So as we are finishing the 1.0 cut of WebVIs late last year, it became pretty clear to us that there is a knowledge gap with our customers to be able to effectively use web servers. And WebVIs are not very useful if you don't have them in a web server that people can access. So we thought it was very important to build this type of functionality in the System Link Cloud. So you build a package in LabVIEW, it's all built in, very straightforward way to do that. And then you go to System Link Cloud, you click upload, you select the file, it uploads it, it's now posted and globally accessible. We have some very coarse-grained sharing options on WebVI hosting today. It's either public or it's private. If it's private, only you can view it. If it's public, anyone who has the URL can view it. Clearly, there's a lot more we can do in this space. And we want to talk to you guys about how you work. Because how we define a more sophisticated sharing and collaboration features on this service needs to match how you guys work and how you work with your teams or how you sell to your customers. So this is an area of intense interest for us. Another feature, it's not quite yet available in the beta. If you really want to see it, I can show you how you can put a feature toggle in to look at it, is Dashboard Builder. So WebVIs and dashboards sort of feel like they're very similar today. And it's in part because the block diagram of the WebVI needs to continue to mature in order to express the full power of the LabVIEW programming language. But we know that monitoring is a really common application, just extremely common. And we wanted to create a better tool for building a monitor application very quickly. And so we're going to continue to see this tool evolve and mature because we want it to be one of the best-in-class dashboard tools available on the market.
You might mention that you can see some of these on the floor.
Oh, yeah. So as I mentioned earlier, while we're still trying to get set up, we have demos using Dashboard Builder and demos using WebVIs, all getting their data from System Link Cloud available on the expo floor. So this next bit is about security management, but I'm just going to take an aside because I think I've actually kind of left a slide out here. One of the other things that we do host that's not clear is these data services, right? So using these data services that are hosted in the cloud is really nice because that means I can pull my phone out and load my WebVI and have a guarantee that there actually is a true route between my phone and where the data is. So that's very, very powerful. But we know that open and ubiquitous access is really great until someone you don't want starts accessing things. So having a security story is really important to us. And we have industry standard security built into this product. We're leveraging all the goodness that the cloud provides and also our own knowledge and know-how through a lot of experience building these types of services in order to build something that's really secure. So all the data that's flowing through System Link Cloud is all TLS encrypted. It's all HTTPS. So no one could man-in-the-middle attack you and see what's going on inside of your data. For applications, like a compact Rio embedded application or maybe a desktop application doing DAC, you don't use your NI.com credentials. We don't want you to put your user human login credentials into your code. So we've built a service for producing API keys. API keys provide authentication for machines. It's a big long string, and it says, hey, I have access to your account. Now we have this concept, you'll see it says default policy there, that API keys attach to. The policy concept defines the authorization of the device. So authentication is sort of like the key that gets you in the door. Authorization says what you can do once you're in the door. So doing things like, hey, this API key should only be able to publish data. I'd never want it to be able to read any data. And you know what? The data that it publishes need to be really, really narrow. It needs to only be these specific tags. I never want this device to be able to touch any other tag. You could create a security policy that defines that and an API key to go with it and then have that level of insurance. Hitting on this a lot, it's our NI.com credentials for all of our user applications. So if you log in to systemlinkcloud.com, you have to authenticate yourself. If you're looking at a private hosted web application, you'll also be asked for authentication credentials there. And there's a lot more we could eventually do in this space. And finally, we do deliver this continuously. And continuous delivery, as many people who I work with will know, is this annoying topic that I will not let up. I talk about it endlessly. But having been able to achieve it in the way that we've achieved it with System Link Cloud is really powerful, and I cannot encourage you guys enough to learn about this concept and try to apply it to your own businesses. We, as Michael mentioned, have hundreds of deploys going live since our initial release in March, and we deploy tens of times weekly. We have a ton of confidence in our ability to deploy. And that might seem scary at first, but that capability allows us to react to problems or security vulnerabilities or other types of attacks that might happen on the system very, very rapidly. And I always thought to myself, working on shared variables for a really long time early in my career, that part of the problem with shared variables was we didn't actually have real applications that we were running that would surface the types of problems our customers would run into. Imagine having a dedicated person from NI that all they did was make sure that the shared variable engine kept up. This is essentially that and so much more. Okay. Finally, we consider System Link and System Link Cloud to have this open architecture. What do we mean by that? Our services are all accessed through HTTP, and they're RESTful. And HTTP is really nice because every language out there has an HTTP client and can implement our client and be able to access it. Right now, we probably would just provide you API documentation. You'd have to roll it yourself. But we're looking at using tools and technologies for describing our web services in more detail, technology called Swagger, that'll help us bring more first-class clients to market in more languages for lower cost. And they think that's really important because LabVIEW is great. We all love LabVIEW. We were at the LabVIEW conference. It is an amazing tool, but sometimes I can't use LabVIEw. I have to use Python or I have to use C# because that is within the requirements, whatever they may be, of the application. We still want people to be able to take advantage of this great technology that we're building, and that's why. And that helps us get to things like non-NI hardware and just be able to talk in other languages. All right, so go to ni.com/systemlinkcloud and learn about some of these details that I talked about. It also has links to push you towards the application process for the NI Technology Software Preview Program. Let's go back to our original hypothesis. So the cloud is transforming our industry. And with tools and technologies like System Link Cloud and other IoT software that's available to us, we're going to see changes in how we build things, like how we're manufacturing. Being able to take a lot of data from a lot of different devices along a smart manufacturing line and centrally aggregate that information so that we understand better when a machine might be damaged. We are able to react more quickly to unplanned downtime, and we have more insights into the capability of that. Monitoring distributed fleets. This could be cars. Actually, there's a lot of amazing technology vendors out there that do fleet vehicle management. It probably would be difficult for us just to step right in there. But doing things like monitoring geographically or distributed applications like windmills is not too far off. And with the rise of things like 5G, we could save a ton of money by not having to run cable. Cable, and for these types of things, it's hugely expensive, very fast. 5G means you can have smart devices on all of these big fleets, generating data through cell networks, ingesting it into the cloud, and making it available anywhere. And of course, being able to access your test data from anywhere. Maybe you're on vacation, like our friend over here on the right. Probably what's more likely, though, is you have a system that is producing data somewhere. It could be in another country. It could be in another building on your campus. It could be in a room that's super locked down, like an environmental chamber. It's a huge convenience factor to be able to pull out your phone and see what's going on. This definitely plays into the narrative of how the cloud can enable us to be able to react quicker to problems so that we have higher uptime, higher throughput through our test systems, and so on and so forth. So that's our presentation. I encourage you guys to go visit System Link Cloud. And just wanted to open up to see if there's any other questions, either about this product that we described or even just general questions about cloud computing. All right, thank you guys so much for your time. We really appreciate it. You can go enjoy the rest of the week.